Okay, now that we've covered the midpoint formula for calculating the price elasticity of demand, let's actually apply it. Now, what I've done is I've constructed a demand curve here, and there's a couple things that's different between the demand curves we've been looking at with no real numbers in them. First, I've put numbers in them. So for instance, at a price of $5, the quantity that would be demanded is 5 units. At the price of $4, the quantity that would be demanded is 10 units, etc. Furthermore, I've connected the ends to the vertical and horizontal axes respectively. So at a price of $6, 0 units would be purchased. And if the product were given away for free, there would be 30 units of the good that people would want. Now, so what we're going to do is we're going to apply the elasticity calculations to this curve. Specifically, we're going to apply it at point 1, point 2, and point 3. You'll see why in a minute why I don't use these points sequentially. Having said that, let's look at calculating the elasticity of demand at point 1. Now again, we're using the midpoint, so the midpoint formula. So the midpoint of the calculation would be at a price of 4 and a quantity demanded of 10. In order to do that, we have to change prices around that point, okay? So we'll change prices from $5 to $3, which means we're changing quantity demanded from 5 units to 15 units. Now remember, it does not matter at all, does not matter, since we're taking the absolute value of it, what direction I move in, whether I go from a price of 5 to a price of 3 or a price of 3 to a price of 5. That's the nice thing about using the midpoint formula, and the nice thing about using the absolute value of whatever our calculation is. So let's go ahead and apply the midpoint formula. So we'll apply it right here. So E sub x equals, okay, so Q1 minus Q2, so let's just say 15 minus 5 divided by 15 plus 5 divided by 2. Okay, so that is our change in Q. Okay, I'm moving from, because remember, I'm moving from a price of 5 to 3 or vice versa, and the corresponding quantity demanded will be 5 and 15 units. I take that and divide it by the price change, which is 5 minus 3 divided by 5 plus 3 divided by 2. Okay, and I take the absolute value of that, and that equals 10, okay, 15 minus 5, divided by 20 divided by 2, which is also 10. I divide all that by 5 minus 3 is 2, divided by 5 plus 3, which is 8, divided by 2, which is 4. Okay, so this gives me 1 divided by 1/2, okay, which equals what? 2. Okay, now remember the categories that I placed our elasticity values in. If the elasticity value is greater than 1 in absolute value, which this is, we call this elastic demand. So at point 1, elasticity value equals 2, which implies that demand at that point is elastic. Okay, it's elastic. Let's calculate another one. Let me just clean that up right there so it's not as confusing. That's supposed to be like an arrow, okay? Oh, my drawing leaves something to be desired. So let's calculate now elasticity of demand at point 2. Okay, now at point 2, we are, if I'm calculating the elasticity of demand there, then we're going to be moving prices from 3 to 1, because remember 2 is at the midpoint, okay, and this is the midpoint formula. So to calculate the elasticity there, we have to move prices around that midpoint, okay, which means we're going to be moving quantity demanded between 15 and 25, okay. So at a price of 3, quantity demanded is 15. At a price of 1, quantity demanded is 25. So let's calculate our elasticity values. So we look at the Q's, that's 25 minus 15 divided by 25 plus 15 divided by 2, and that is over our price change, which is 3 minus 1 divided by 3 plus 1 divided by 2. And again, we take the absolute value of that. Of course, there's no need to, again, because it doesn't matter what values I place as P1 and P2. I can make them positive. Okay, so just don't get real concerned about that. It's not an issue. What does this equal? This equals 10. Okay, 25 minus 15 is 10. Divided by 40 divided by 2, which is 20. And that is over 3 minus 1, which is 2, divided by 3 plus 1, which is 4, divided by 2, which is 2. And of course, this equals 1/2 over 1, which equals 1/2. Okay, and this is less than 1, of course. So we go back to the previous video. We see that this we call inelastic demand. So this elasticity value is equal to 1, which implies inelastic demand. Okay. Now let's calculate our elasticity value then at point 3. Now you can probably already guess what it's going to be, but we're going to calculate it anyway just to get some practice in. So at point 3 then, okay, I'm going to have to move prices around a price of $3. So I'll be moving prices from $2 to $4, and I'll be moving the corresponding quantity demanded from 10 to 20. So at a price of $4, quantity demanded is 10. At a price of $2, quantity demanded is 20. Okay. Now, our elasticity calculation is going to be, okay, change in quantity, which is 20 minus 10 divided by 20 plus 10 divided by 2, and that is all over our change in price, which is 4 minus 2 divided by 4 plus 2 divided by 2, and of course that equals 10 over 15, and that is 2 over 3. Of course, the numerator is 2/3, and of course the denominator is 2/3. 2/3 divided by 2/3 equals 1. And remember, we called this unit elastic. Sorry, that's supposed to be E equals 1/2. Sorry about that. So this at this point, at a price of 3, our demand is unit elastic. Okay. Make sure you change that in your notes. I accidentally had 1 here. It's actually 1/2 down here to price of 2. Anyway, you get the point. So I have unit elastic values at a price of 3. Okay, so what do we see here? We see something interesting, that given this demand curve at a price of 3, Okay, demand is unit elastic, but above a price of 3, demand is elastic, and below a price of 3, demand is inelastic. And that makes sense, right? And remember, the more elastic demand is, means the more sensitive people are to a change in the price of the product. Well, if the price of the product is already relatively high to begin with, a further change in the price, people are going to be more sensitive to a change in the price of that good. But if prices are relatively low to begin with, then people aren't going to be as responsive to a change in the price level. I mean, if the price is already really low, changing it by 10% is not going to make you change your consumption that much. But if the price is really high to begin with, changing the price of the product by 10% may cause you to purchase substantially less of the product in percentage terms. The other thing that is interesting here is the fact that, it seems like I'm going off in a different direction here, but I'm really not. How do you calculate the amount of money that goes into a store's cash register? And that amount of money is called total revenue. Okay? So a store sells some units of a product all day long, however many units that is. They multiply that times the price of the product, and that equals their total revenue. That equals the amount of cash that goes into a cash register. Okay? Where is that largest on this graph? Where is that largest on this graph? Well, if we look at this graph, if we start calculating revenues, P times Q at different locations, and let's just take points 1, 2, and 3. At point 1, total revenue is P, price of 4, quantity sold of 10, is 40. Okay, and that's at point 1. Total revenue at point 2 is at a price of 2, quantity sold would be 20. So that would be, again, at point 2, revenue would be 40. At point 3, however, that is a price of 3 and a quantity demanded of 15. So P times Q at point 3 is actually equal to 45. In other words, if I price my product at a price of 3 and I sell 15 units, I'm stuffing as much cash into the cash register as I can. I can't fill the cash register anymore by pricing the product at any other price. Okay, let me repeat that. At that price of 3, total revenue is 45. It's higher there than at any other price level. Okay, meaning that total revenue, or the amount of cash I cram into the cash register given the price of my product, is largest at a price of 3. If I raise the price to 4, some people may think, well, just raise the price and you'll make more money. No, that's not the case. I actually make less money. Or some people may say, well, lower the price, you'll sell a lot more and you'll make more money. No, if I lower the price to 2, I make less money. Okay? In other words, total revenue wish I could spell again. Total revenue is maximized where demand is unit elastic. Total revenue is maximized where demand is unit elastic. And the last thing of interest that you're going to see is that a price of 3 is exactly at the midpoint of the demand curve. It's between 0 and 6, exactly in the middle of 0 and 6, the vertical intercept in the origin. and a quantity demanded of 15 is exactly between the origin and the horizontal intercept of 30. Okay, so that's our second interesting point. So first, total revenue is maximized where demand is unit elastic, but unit elasticity always occurs at the midpoint of a linear demand curve. So if I know what the demand for my product is, all I need to do is figure out what the intercepts are. Okay, all I need to do is figure out where the intercepts are. If I can find the intercepts, then I simply calculate what half the price is and what half the quantity demanded is. That's where the demand for my product will be unit elastic, and that is where total revenue will be maximized. If I price my product at that point, I will put as much cash into the cash register as I possibly can. Now, warning, we are not talking about profits. We get to profits in later lectures. These are not profits. These are revenues. This is P times Q. A profit is P times Q minus some cost, okay? And that is different than this. But if I'm interested in maximizing my revenues, for instance, if you're in sales, and you get a commission based upon the total revenue that you generate by selling your product, well, then you want to negotiate prices with your customers whereby you try to hit that unit elastic price level for each customer. You may lose some sales, you may gain some sales, but overall, you're going to be maximizing the amount of revenue you generate and therefore maximizing maximizing your commission from those sales.